O Levels Maths Exercise 13A D1 7th edition. We shall try to cover question number 14 in this video. Question number 14 is about finding the area and perimeter of this shape. There is no such shape like this in maths, so we shall divide it into, we shall break it into known shapes, and then we shall try to solve this shape. Now the question is, BOD is the diameter of the semicircle with center OD. The line starting from B and ending at D, BOD, D is over here. I'm going to make an enlargement of this figure as well, so you can well understand it. So we shall do it on this paper. Here I have drawn a circle, because from here I will try to tell you how they have broken this complete circle in different shapes. One sure thing you must keep this in mind, that a circle can be divided into two parts, which is each part is called semicircle, or the circle is can be easily divided into four parts, and each part is then called quadrant. Here we shall deal with all both of these things. We shall deal with semicircles and quadrants in this question as well. So there are different formulas for semicircles and quadrants, and we shall deal with it. So in this question, they have basically, it was a round circle, and they have broken out certain pieces from that circle and have asked us to find out the perimeter and area of that shape. First of all, they have, this is the radius of the big circle, this is the radius of the big circle, and the diameter of the small circle. This dimension, this measurement, here is the O, the starting point of both of these semicircle, and the measurement of this line is 10 centimeter, which is given by them from here to till here. So 10 centimeter is the radius of the big circle and the diameter of the small circle, because it is totally covering the small circle. So the radius of the small circle is half of this line, which is 5 centimeter long. So then they have drawn this line till here. And now one thing more I would like to clear it out. Okay, these arcs which they have made, they are stretched out till this quadrant. This is, as I have already told, that the fourth part of a circle is a quadrant, so they have made these arcs in that quadrant. Like if this is a quadrant, they have drawn these arcs like this. So I am going to draw the these arcs like here. So these lines are not broken in this in the figure, so I am drawing them with my pen. Now what have they done? Now I know that, hey, this is the quarter of this is the quadrant of a circle. So they have stretched this arc from here, they have stretched it through there, and this they have joined it there. So they have asked to find out the area and perimeter of the shaded region. This part is shaded, this part is shaded, and this arc is, these two arcs, the area within these two arcs is also shaded. So we have to take out the area, calculate the area of this shaded region, and similarly we have to take out the perimeter of this area. Now this broken line is not included in the figure. Even this, I drew this line so that you could understand it well, otherwise it is also broken in the line, which means it's not included, it's not a part of the figure, it's not the part of the figure, and only the shaded area, we have to deal with the shaded area of the figure. Now first of all, this one thing more I have forgotten. This line starting from here and ending here is 3 centimeter long, and this is also 3 centimeter long. They have drawn these, they have cut these lines with the identical stroke so that we should know that they are equal. They have not given us this dimension, but they have stroked this line with this, so I understood that this is also 3 centimeter long. This is, if this is 3 centimeter, this is also 3 centimeter. Now I know if this part starting from here to here is 10 centimeter long, then this part starting from here and ending here is also 10 centimeter long, and this part, so but this part they have given us, it's 3 meter long. So if I have to know the dimension of this part, I will simply, because the whole part is 10 centimeters long, so I will subtract 3 centimeters from 10 and will get the required dimension, which is 7 centimeter long. So this length is starting from O center to this point, which is in question as C, is from O to C is 7 centimeter long, and this point is B. This point is written as A, and this point is written as D, and here this point is E. So now we got all the dimensions in this question, and now we are going to solve this question. Now we have to find the perimeter of this shape. Now we have to find the perimeter of this shaded area only, not the entire circle. This part is being cut off from the circle, and they have asked us to tell us the area and perimeter of this specific shape. Now we know that perimeter is the sum of the outer sides of any shape. So how am I going to know the outer side? The outer side of the shaded area. This area is shaded. The outer side of this shaded area is first this small semicircle. So for perimeter, we have to find out the circumference of the small semicircle, then the circumference of the big semicircle. So, and then this is again a circular region. This is again a circular region of a quadrant. Because I have told you this arc is drawn in that quadrant. So what am I going to find? Circumference of the outer side of the quadrant, and secondly the circumference of the inner side of the quadrant, plus this side and this side. If I'll add them together, only then I will get the required perimeter. So first of all, so perimeter is equal to circumference of small semicircle, this area, plus circumference of big semicircle, this area, plus circumference of the outer side of a circular part is always calculated by taking out the circumference of that area. Now this circular region, it is the part of a quadrant, so I will say circumference of the outer quadrant, circumference of outer quadrant plus circumference of inner quadrant plus AE plus this part plus this part. This is not making the inner part of the circle. This line which is here, it is not making the outer part of the circle. This line is making the outer part of the circle, which is from here to here is 7 centimeter long. This is CO, 7 centimeter, or CO line from C to O. This line is not making the outer part of the circle. It is inside the shaded region, and in perimeter the inner things, this part, this is not the inner part. Here it is not shaded, here this part is not shaded, so this line is making the outer part of this shape. That's why I have calculated this. This line is making, this part is not shaded, so this line is making the outer part of that shape. This is inside, both of the sides are shaded, and it is making the inner part of the shaded region. That's why I'm not going to add 3 in that. Now I will calculate the required circumference of small semicircles. This the outer part of this semicircle. So circumference of small semicircle is equal to 2 pi r is the circumference of a circle. I'll divide it by 2 and get the result for semicircle. Pi into r. Here I know that radius of this small circle is 5 centimeter because its diameter is 10, so radius is 5, so I will multiply it with 3.14 into 5 is equal to, I'll get my required answer, which is equivalent to 15.7. Now circumference of big semicircle, this part, the outer part of this shape, this semicircle, this, I know the radius is 10 centimeter, which is given here, so I will circumference of big semicircle is equal to 2 pi r over 2, which is, we are left with pi r is equal to 3.14 into 10, and the result would be 31.4. Now I have to calculate the circumference. I have started like this, from this to this, and now this. The circumference of outer quadrant, this is making the outer part of this quadrant. So circumference of outer quadrant is equal to 2 pi r is the circumference of a circle. I'll divide it by 4. Quadrant is 4, so I'm left with pi r over 2. So pi is equal to 3.14 0.14 and radius is equal to, how am I going to get the radius? Radius is, whenever, one thing you must keep in mind that when I divide a circle into 4 equal parts, then this is radius and this is radius of the outer part. So here the radius of this quadrant will start from this point and will touch the outskirts of this quadrant, so its radius is also 10. So I'll divide it with, multiply it with 10 and I'll get the result, which is equal to 15.7. Now this dimension I know it's 3, so I don't have to calculate it. Now I have to calculate the circumference of the inner quadrant. I have to calculate the circumference of the inner quadrant. So what am I going to do? Circumference of inner quadrant is equal to 2 pi r over 4 is equal to pi r over 2. I'll put in the values. Pi is equal to 3.14 into r. I have to find out the radius of this inner quadrant. So this is, the radius will start from here and end till it reaches this inner quadrant. The outer quadrant, the radius started from the center and touched the outskirts of the quadrant. Same likewise, the radius of the inner quadrant will start from the center and touch the outskirt of that quadrant. So the radius is 7 centimeter from here to here. I have subtracted 3 from 10 because this is 3. And these two are equal because they have told us so. They have stroked us them with same line. So the radius here is 7. So what the result I am going to get is 10.99. I will round it off till one place of decimal. So the next digit is 9. So one will be added to this 9. It will become 10. So 0 will left here and 1 will be added in this. So 11. So the circumference is 11. Now I have calculated all the unknowns. I know the value of this now, which is 15.7 from here till here. I know the value of this from here till here, which is 31.4. I know the value of this point, which is 15.7. I know the value of inner quadrant, which is 11 from here to here. I know the value of this because this is also making the outer part of the shape, which is 7, because the radius of the bigger circle is 10 and I have subtracted 3 from it. So this is 7. Now I will add 15.7, this 15.7 plus 31.4 plus 15.7 plus 3 plus 3 plus 11 and plus 7, and I'll get my required answer. So I'll do the maths here. What am I going to do? I will write perimeter is equal to this 15.7 plus 31.4 plus again 15.7 plus this 3 because it's also making the outer part of the shape, plus 3 plus 11, this 11 plus 11 plus this 7. and which is equivalent to 83.8. Now we have to find the area of this shape as well. Now I will break this shape into known shapes. So this shape is a combination of a small semicircle plus a big semicircle, then the area of these arcs, the area confined in these two arcs, such shape is called arc in maths. We just have to find the area confined between these two arcs. How are we going to find the area confined within these two arcs? First of all, I will find the area of the entire quadrant. This part. I will find the area of this entire quadrant, and then I will subtract the area of this white quadrant from that area and will get the required result. So I'm going to proceed. First area will be area of small semicircle is equal to pi r square by 2 is equal to 3.14 into r, as we have already calculated. Radius is 5 into 5 into 5 divided by 2 is equal to 39.25. This is the area of small semicircle. Now area of big semicircle is equal to pi r square over 2 is equal to 3.14 into r. Here this is the big semicircle and its radius is 10. So into 10 divided by 2, and I will get the required result, which is equivalent to 157. So now I will have to calculate the area of this confined place between this quadrant. So what am I going to calculate? First of all, I will calculate the area of the big quadrant. Then I will calculate the area of the small quadrant. It's also a quadrant of a circle with radius 7 centimeter, and then I'll subtract them and I'll get the area of this confined place. So area of big quadrant is equal to pi r square over 4 is equal to 3.14 into big quadrant. The radius is, this is the big quadrant, and the radius is starting from the center and touching this quadrant, so it is also 10 centimeters. So this is equivalent to into 10 over 4, and the result is 78.5. Now I will find the area of small quadrant. The area starting from here till this and this is equivalent to pi r square over 4 is equal to 3.14 into r. Here r radius is starting from the middle central point and touching the outskirts of this quadrant, which is 7 centimeter, into 7 into 7, which is equivalent to 38.47. Now to find the area of this confined place between these two quadrants, I will have to subtract the area of both these quadrants. So area confined by two arcs is equal to, I will just have to subtract these values. I will subtract the area of the small quadrant from the area of the big quadrant and will get the area of this place. So I will subtract subtract the area of small quadrant from the area of big quadrant, and this is equivalent to 40.03 or 40. I'll take it as 40. Now area of shape, I'll just have to add up all these areas. This is 40, leaving these quadrants, leaving behind the areas of these two quadrants because we have solved them out by subtracting them. So plus 157 plus 39.25. I have just written 39.25 plus 157 plus 40, and I just will get the required result, which is equivalent to 236.25 or 236 centimeters square.